Okay, this is problem number 14. So let L be a linear transformation from Rn to Rm with matrix representation M. We want to define some things. So what is a column space of M? So the column space of M is the linear span of the columns of M. Okay, and please write incomplete sentences when you take the exam. Don't just say the linear span of the columns of M. Write incomplete sentences. What is the row space of M? The row space of M is the linear span of the rows of M. Okay? Next thing that we want to define is what is the null space of M. The null space of M, there's many different ways to write it, but the bottom line is the null space of M is the set of all vectors that satisfy MV is equal to 0. Okay, and really we should say, if we want to be a little more complete, we shouldn't say all vectors. We should be it's fine, but just to be a little more complete, we should say the set of vectors in Rn that satisfy MV is equal to 0. Just all the vectors that get mapped to 0 by this transformation. Okay, now I'm going to do number 4. So assume that M is equal to 4 and N is equal to 5, and the rank of M is 3. Then what is the nullity? Well, we're going to use the nullity plus rank theorem. So the nullity plus rank theorem says that N is equal to the nullity plus rank. Okay, and remember, rank is the dimension of the column space, which is just the number of pivot columns in the row reduced matrix, and nullity is the dimension of the null space, which is just the number of free variables. So then N is just going to be equal to the nullity plus the rank. Okay, the number of columns is equal to the number of pivot columns plus the number of non-pivot columns is basically what this is saying. Okay, so we know that N is equal to 5. So since N is equal to 5, 5 is equal to the nullity plus the rank, which is 3. So nullity is 5. Or sorry, is 2. 5 minus 3 is 2. So the dimension of the null space is 2. Okay, 5, using your answer from part 4. Okay, I want you to use your answer from part 4 is M injective. So M is injective. M is not injective because the dimension of the null space of N, or null space of M, is greater than 0. Okay, so in other words, there's a vector that satisfies MV equals 0. So there's a two-dimensional subspace of vectors that satisfy MV equals 0. So there is a two-dimensional subspace of vectors, or a two-dimensional subspace that satisfies MV is equal to 0. So in other words, there is more than one solution to MV equals 0, so it's not injective. Okay, using your answer from part 4 is M surjective. Okay, well, the rank, so L is a transformation from R5 to R4. But the dimension of the column space is equal to the rank, which is 3. So the dimension of the column space is 3. But the dimension of R4 is 4. So not surjective. So basically there's like a one-dimensional subspace of var4 that is not in the image of M. Okay, so that's the answer to these questions. So if you are confused by it, that's fine. Just think about it some.